preparing for this last update.
Hello, everyone. You know, they say cloud costs are elastic, which I think is true because it keeps stretching every month. So I think it has taken up some pretty hefty yoga, which is causing the cost. Let's see if we can get them to relax into a more budget-friendly pose by end of this session. Hello again, my name is Swati. I am a product manager at booking.com. I have been joined by my colleague,
Pedro. I'm site reliability engineering in the security department.
We at booking.com works in security platform services. Yeah, which is a horizontal platform within security. Our main focus extends from managing SIM and SOAR, which we'll be discussing later on, to supporting our stakeholders. We have been instrumental in enabling the fraud prevention team and overarching cybersecurity team to become more effective, efficient, and faster in adapting to changes. Today, we are here to merge the world of advanced security and efficient resource management, showing how Elastic is empowering us in driving cost optimization and transparency in our systems. Yeah, it's a quick rundown of our agenda today. I'll be touching more about what cost transparency and cost optimization looks at booking.com. And then Pedro would be covering more technical details that how did we achieve it. So why cost transparency? Before I delve into the world of cost transparency and optimization, I can't help but compare it, the journey of our managing our own platform to planning a vacation through booking.com. Let me draw some parallels. Imagine you're planning this dreamy vacation to Hawaii beaches, and which is similar for our case in managing the platform. Even though you start off with a fixed budget, you soon realize that the running cost of the platform, similar to the sea-facing room, is constantly is not exactly what you thought of, and it has been increasing. Other scaling expenditures such as extra compute or database storage costs, like flight cost, are dynamic and keep on increasing. And we shouldn't be forgetting about the cost similar to hidden fees for extra baggage, which is operational cost in our case. So soon you realize that the actual spend is far more than the budget you planned for. And here, the struggle didn't end here. We have been struggling to track also the platform spend and tracking each expenses for the platform. Apart from this, we have been also struggling to correlate these expenses to the business priority, similar to correlating the expenses with the joys of the trip. Is it like trying to measure the happiness each beach day brings you? Is it really about the number of sand castles you built or the number of hours spent sunbathing? So we don't really understand that how can we relate the spends that we are doing on the platform to the business priorities. Lastly, the $1 million question, that how do you communicate and measure the value created by platform to your business stakeholders? Is it only about the about the costs and expenditures, or is it something more, the efficiency, effectiveness that you're bringing to the platform? That's where we stand with the platform. And cost transparency is like a travel guide, helping us making spending as clear, empowering us to discuss costs, and also shifting the ROI conversation from platform owners to stakeholders in a more informed, data-driven manner. For us, we would be looking at how the operational efficiency, customer satisfaction, and strategic advantage through cost transparency enabled us and empowered us. Now, Pedro would be, yeah.
Okay. So let's see how we try to achieve all these wonderful things. So cost reduction, how to pay less, because everyone likes that, right? So cost reduction is, it's not just cost reduction, it's actually a problem of optimization. It's not, we still want the service. So it's about how to have the same service, but using less resources. So it's basically an optimization problem. As with any optimization problem, it's important to understand the situation, what you're optimizing for, because it's often not a question of just using less, just paying less, just cutting features, but a matter of what you optimize for, what you want to pay for and what you don't care about doing without. So first thing is, I'll briefly explain what we use Elastic for. We use it for SIEM, which in the business is security information and event management, which is basically a system that stores all security-related data from our platforms in the company. And we use that for, that information for detections and investigations and audits and whatever you need for in security. And well, how we use it, how it looks like is or the needs of this platform in relation to data is it's a very high volume of writes, very intensive on writes. We write 500,000 events per second, and the reads are comparatively few, and they can take longer. We don't care that much about the latency of the reads. Of course, they have to be usable, but they can be allowed to be much slower. Some are even manual search for the agents, the analysts, so they can take a few seconds, and it's not very important. So this is a very wide overview on how we do this, how we send the data to Elastic. We have Elastic fleet agents that send the data straight to Elastic, but mostly our data comes through Flink indexers. It's system stream processing that indexes the data, and the data comes. The services send the data to Kafka, which the indexers push into Elasticsearch. And for some other platforms that don't support sending data to Elastic, we have some. We have a service that uses Logstash and provides a HTTP and a syslog endpoints that the services can use to push the data, and then it's sent to Kafka. So basically in a very abstract, very high 10,000 meters view, that's basically it. Some of the constraints and considerations that we need to have. We have a lot of storage, 1.5 petabytes, and throughput it's also quite high, 3 gigabytes per second. And the criticality is interesting because, yeah, of course, everyone wants this to keep going. Nobody likes when the service drops. But completeness is much more important. So if data is lost, then we may incur in heavy penalties and all kinds of things that you don't want to know about. But if the service is out for, let's say, 1 hour, it's bad. But if all the data is there at the end of the day, then it's not so bad. If data is lost, it's so we need to optimize also for that. We have to take that into account in our operations and all the things we do. And some challenge that we face with this is basically visibility and the changes that we can do. the Elastic platform is very complex, so it's very hard to know, at least for us, how the cost will be impacted when you make a change. For example, when you reduce the retention of some data or increase it or whatever, it's hard to get a good view on how that will impact your the amount you pay. But there are some estimates that you can do, and well, your TAM can help. If you don't have a TAM, I recommend get one, 5 stars out of 5. We'll recommend to family and friends. And also, it's also hard to know how the search, how the results will be impacted when you do a search, how much longer they will take or that. But yeah, there are some things that you can do to get some estimates about that. But yeah, in general, it's, so that leads us to a strategy of trying and measuring. So in the beginning, we started with very hot data. Yeah, we put the data in the shiniest and most expensive tiers that we could find. And also to make, because we didn't know what to expect. We didn't know, it depends a lot on what the users will do, on what, it was all new for us. So we tried to give the best and fastest service that we could. Also to favor adoption, because if you're one of our users and you start using this and it's slow and clumsy and whatever, then you don't want to continue. But so we tried to show them the best we could. Then we started to cool it down with many initiatives. We reduced the hot tier quite a lot. Then we replaced the warm with cold altogether. And then we started moving from the cold to the frozen tier progressively. And at some point along the way, we realized that the hot tier, we didn't need so much for the query speed. Many queries were were done with data that was very like in the first 36 hours or 2 days or even less. So we realized that the main use for the hot tier for us was not storage, but indexing speed. So we started to size the hot tier, not for its storage capacity, but for its compute power. And so that brought us some other avenue for optimization. So right now, well, what we went is from this to only 36 hours of hot, no warm, a little bit of cold, 5 days in retention, and then the rest all in frozen.
We're singing now. Let it go.
Yeah, let it go. Yeah.
I like it.
David was singing that when we was decreasing the. And that brought us more or less, because it's hard to know precisely, but about 70% reduction in the price we pay for the same amount of data. So let's say 70% increase efficiency, right? And you'd ask, yeah, but what do the users feel about that? And again, it's we don't have a precise tool to know how their queries are impacted, but in general, from what we see, there are not much, the query times have not increased much, and they are still happy with it. So
Nobody's coming after us.
Nobody's coming after us after. So the performance is still perceived to be acceptable, right? And here is, you see our trip to Arendelle from hot. First step is we reduce hot from 7 to 3 days. That got us about 20% reduction in the cost. Then we switch over to cold, 30% more. And then we implemented mostly frozen. And you see, we knocked off some more percents. But it has to be said that these are milestones, and I'm correlating them with the changes in actually one of the retention policies that we have, which is the oldest one. But of course, there are other things that we did. First, this is just for to have a measure, but other data sets changed in different ways. And some other measures we took along the way that can also had an impact on these reductions that I showed are, for example, this. We reduced the availability zones that we used from 3 to 2. That allows us more granularity when scaling up or down, because instead of just adding servers in 3s, we add them in 2s. So, and we didn't care much for the reliability. It's great anyway. And we made improvements on how we calculate the capacity. So as time went on and we used the service more and we saw more what the use case for users was, we learned to optimize the sizes and the retention policies of each of the data sets and also the clusters. So that is also in part responsible for the savings. So it's not only a change in the retention tiers. And of course, we changed the retentions of data sets differently. This is mostly an example. One of the tools that we use for the optimization is, for example, this dashboard, which also our TAM helped us create, which shows us when we have it processes a log of the logs of the queries and shows us what age the data that comes there, what's the age of the data that the query returns, so that we can know if we can adjust the data tiers a bit more. And well, the dashboard says warm, but that's because when we switch over, we didn't change the labels and the name. So bear with me. It's not very tidy, but well. And well, this is and what else? Yeah. Well, you see here, we can see, for example, the queries for this data set, let's say this. We can see that 87% comes from returns data from the last 8 hours, and a few more from the 12.5. So we know if we remove the cold and move everything to frozen, this will not be severely impacted, right? So, and we can see how much impact this will have. And why 8 hours? Because we are planning to also reduce hot tier further, because it's the most expensive tier, and you will see more about that in the future. Another thing that we are planning to do is use ARM nodes, which are the ARM node is a bit more expensive, or it's more expensive, but it packs more compute power. And since we are, as I said before, since we are using the hot tier mostly for compute, not for storage, then we estimate that we can save about 20%, because they are more expensive, but we can use less of them to have the same compute power, which is what basically we need to size for. And another possible, plan that we have is doing the Finnish approach, jumping from the hot sauna into the frozen waters, eliminating cold altogether, and well, we'll see how that goes. So Of course, you want to take informed decisions for all these changes as much as possible. We need to know what we're using for, where we're using, who is using what costs are our stakeholders or users creating for us, and who to blame when something goes up and it's costing us a lot more. And so one challenge here is that this is the dashboard that you have in Elastic Cloud. And you see it's nice. You have what you spend every month and in which clusters you spend how much and whatever. But there's a few problems with this for our use case. It's you only know per cluster, and we have a lot of clusters that are shared that have many data sets inside. We have some that are dedicated to one data set, but about half of them are shared. So we want to know for those shared clusters how much each data set is contributing to the cost. It also does not show the cost per data tier, and we want to know how to optimize them. And finally, it shows the values in ECUs, which I guess is Elastic's cryptocurrency or something. we would like to know the value in euros or something that's more easily understandable and more easily relatable by your management. Oh. We created something that to extract this data. It's basically a Python script. We run it in Kubernetes. It's scheduled every hour to get the data from the Elastic Cloud billing API. The data is already there. This is the call, actually. If you see the slides there, you can click there and go to the documentation. It grabs this data and divides the cost per data stream. Just calculates the relative amount of data in each data stream and makes calculates how much prorates how much it adds for that, and then aggregates the cost per tier and data stream. The tier, you know, it's the node. It's in the node. It's a configuration of the node. And then it converts with the magical formula from ECUs to euros, and then sends all this nice data into an index in Elastic, where once in Elastic, you can use that data to create fancy dashboards to impress your managers. And that's basically it. And the result is this. You can see we have the cost per each data stream, ordered by relative cost. But of course, I cannot show you the exact amount, but the percentage should be enough. Like so, our managers would probably like to go to the first ones and say, "Yeah, well, what do you have there? What are you using?" And you can create this sort of graph for the managers to use their fancy Pareto skills and see how they can optimize by deciding if the data is necessary or not. And yeah, and this is also interesting. It's the cost of, well, again, it was warm, now it's cold for us, but yeah, bear with me. Of course, I again cannot show you the amounts of money, but to give you an idea, this is how much of the cost they produce. So you can see the hot tier, it's 75%, more than 75%, 3/4 of what we pay. And if you remember from before, that's only 1.5 days. So 3% of the storage is 75%, 76% of the cost. Of course, this is an unfair comparison, because this one is sized for compute and the other ones are for storage. But this is a fair comparison. The call is costing us for 3.5 days of retention, it's costing us 14%. and the frozen for 40 days for 10 times more, it's costing us half. So that's why we want to go Arendelle full scale. So that's basically it. Key takeaways from this: hot tier is expensive, frozen tier is cheap. Be aware of what you are using this for, because it's very important. And well, our approach has been to do things, think before, of course, but do things and then measure the change, how it impacts, make a change, repeat. That's, and of course, this, what I just explained is for our use case. Your experience will be completely different, probably. You have to take that into mind. So don't try this at home, or if you do, be mindful. Don't come later saying, yeah, I saw this presentation from this guy and he told me that I just had I move everything to frozen and it's great. I pay less and now nothing works. So don't blame me.
One thing more that I want to take a note of is we are actually paying, even after these optimization, we are paying even more bill to Elastic than earlier.
But we're doing many times more with it.
Yes.
So,
and that's because we have, what we have done with this whole cost transparency and optimization effort is slowed down the exponential increase of keeping the same data. So if we would have not done this, the bills would have been, let's say, 10x. Now we were able to at least control it to 2x. So that's the main takeaway we want to for today's presentation. Otherwise, I don't think Patrick would have allowed us to.
Yeah, because you would say, oh, some guy is teaching us how to pay less pay less to Elastic in an Elastic event. They will be pulling the cable, but no, they are really happy with it. Because we're not paying less, we're paying more. We're just doing more, much more with the same price.
That's the right remark. So you're doing much more. You're serving many more use cases with the same capacity.
Exactly.
That's exactly what we want you to do.
Exactly.
Our CFO may have a different opinion, but we really love what you're doing and how you maximize it. But as you say, you need to look at what you're doing, because for your use case, it may be okay to only keep stuff for X amount of days, and that it could be fast enough. But if a lot of people are still looking through the frozen tier data, they may not be so happy. So you really need to understand the user behavior to maximize how you can apply this. But you guys maximize it, so it's a good example.
But if you're, for example, if you put an Elastic, your information that you search on a search box in the web, and you move everything to frozen, then probably a search will take like 30 seconds for
it will have a bit of an impact.
That will not be smart, right? So be mindful. Any questions? Yeah,
yes.
I don't know who was. You'll both get that chance.
I find it interesting what you said about not actually finding a way to measure performance.
Mm-hmm.
Like what was the bottleneck there? Because I thought Elastic had like these metrics out of the box, or don't.
The metrics for query performance.
Query performance, yes, indeed.
Yeah, now we're. The thing is, we need to have this metric and correlate them to each data set. And you have the slow query logs that you can leverage for that. But yeah, today, that guy over there created a dashboard for us to see that. But before it was, what we had was this dashboard that we created with TAM, correlating the age of the information returned for each one. But I mean, what we want to know is, the data that's hard for us to know is not what a query takes, but if the query is taking long because it's taking data from some data for frozen, for example.
The other metric, like if your customer stays waiting 10 seconds more than before, you do have.
Yeah, that we can get, but it depends on what queries the customers do.
Currently, it also depends on, because our stakeholder base is so large, like it's from fraud to cyber and other kind of security teams. So it's hard to determine that what query performance works for one team would not work for other teams. So maybe it's if they are in the middle of incident, they might require more query performance than for their usual analytics activities. So we are trying to work on identifying the use cases first, and then based on that work on what actually performance query would work for them.
Or if they have a detection, for example, maybe they need a faster response than if they go and manually search for an investigation, a punctual investigation, then maybe that's.
I know you said you don't really measure it, but have you done any benchmark on the same queries? What is the response time for the frozen tier and the cold tier? Like, I know you mentioned like 30 seconds. Is that the ballpark that we're talking about? Is it like seconds or is it hours?
No, it's not hours. What we say, it's seconds. It's like I think today we were seeing like 30 seconds or something like that was taking there.
Yeah, at worst,
But-
4 minutes.
But it depends a lot because in frozen, what you have is you have a cache. If the data is in the cache, then it's basically the same as warm.
I don't know.
But if it's not, then it takes considerably longer because it has to go fetch from S3. So it depends on what the users do. That's also the problem. We create the platform, but then the users do whatever they want. Or for example, they query some field for in all the data sets, whatever, they don't care. They just put select asterisk from, right? And they query, they end up querying 1.5 petabytes of data for a search instead of selecting the correct data set. So it's, yeah, that's why you need to start seeing what your users are doing out of it.
I'm curious about the architectural choice of Kubernetes for that Python script. If you can dive a bit deeper.
It's nothing fancy. We just created a scheduled job.
Okay.
And it's just a Python script that runs every hour.
That's why, because it seems unjustified to use Kubernetes for that.
Yeah, it's not.
Okay.
It's just because it was easier for us to implement.
And drive the cost higher than it should be. So that if you can
Yes, I
optimize
agree,
it, then-
but we needed to, I mean, it's a cron. You can pop up a server and run a cron. But for the platform that we have in Booking, that made sense because it's easier to maintain and it's, we consider other things. That's why I said we use a Kubernetes, but you can use whatever else and it's probably gonna be smarter. But thanks. Yes.
Yeah, something occurred to me. You're handling huge quantities of data, I guess. And I'm going to ask the question that I guess your senior management are asking you. Is there any application for the current crop of AI technologies that are coming out to help this and get better queries?
Probably, yes. Yes, I mean, the managers always want to use the buzzwords. So they of course, want to use AI. We're not so quick to jump on the, but yes, there are applications, of course, and we're exploring them. But yeah, nothing I can talk about currently.
You talk a lot about the reducing cost. What investment does it take to reduce the cost?
That's a good question, and the managers don't care. But yeah, it's hours of work, and I mean it's hours of work, which is not an inexpensive amount because IT people get big salaries. But we pay. I cannot tell you how much, but we pay a lot for this.
In terms of percentage,
I don't know. I cannot. I don't have any figures that I can.
We do have a calculator on the web where you can make your own configuration and the list price gets up. So if you're curious about that, you can do that and do the math yourself. But of course, we cannot disclose anything.
I don't think they will have a calculator for the price of your man hours, but for the elastic part, yeah.
I'm quite interested that we're developers and we're talking about cost optimization. Is this a typical topic of concern within development teams within Booking, or is this globally organized?
We don't care. It's a concern for the manager, so it's a concern for us. I mean, yeah, of course, we want to optimize always. But yeah.
Are you doing this across Booking, or is this per organization or team or within Booking?
I think any organization is concerned. After you have a service, then the next step is to optimize it, right? Always. So this is part of that. So yeah.
I would assume that optimizing was normally around performance, but now you're really optimizing around cost. That's really interesting.
We do both, but just this talk is about the optimizing the cost. We can have another one about optimizing performance. But of course, you optimize performance up to the point where there's a balance, right? I mean, if we wanted to make it the most performant, we put everything in hot, and you see what will happen. These guys will be really happy, but then the service will probably not be sustainable, and they will be out of a business. So that's why they're happy that we are talking about this. But there's a balance, right? That's why we started with what we thought would give us the maximum performance, and then we started seeing how much we can push it without the clients complaining. So,
I've been able to do more with less cost. Or
yeah,
same cost.
About the doing without the customers complaining, I find that quite interesting.
Yes.
Have you considered using, I don't know, like SRE approach, having SLA in our budget and doing like more on a structured way? And if you did, why not use that approach?
Yes. we have considered that. Yes. Yeah, I mean, we do those for availability. Availability is not an issue for the platform.
Yeah.
That, I mean, we're not sacrificing. We're not sacrificing cost for. We're not sacrificing
performance for the
well, we're sacrificing a little bit of performance, but not availability, or we're not making the service unusable for the cost. That's never in the equation. We're just making, or maybe making some cases slower that not very much used, or that can take, for example, some queries that we know it's okay if they take twice as much. Then we optimize so that the other queries that need to be faster, they continue to be faster.
It would be like P99 and I don't know, P95. Do you have anything?
Yeah, we have a lot of metrics for this, and when we do changes, we measure before, we measure after. It's not we're not like randomly saying, oh, let's move these things and see who complains. We measure first. We make an estimate with the help of our TAM and whatever. Of what could happen, and then we make the change and we measure after, and we see. It's not. I make it sound more reckless because it's funnier, but we're serious about it.
Okay.
Any other questions? Have I bored you enough?
One more question.
Are you going to share your fancy script?
I what?
Going to open source your script?
I don't know.
It's actually the technical account manager at Elastic helped us with that. So you should be reaching out to him, and he might be able to source similar one for you.
Yeah.
Yeah. So something not we built, but he built for us. So.
Correct. The technical account manager created, and this guy next to you, he fine-tuned it for our case. So yeah, it's nothing too. It's nothing too customized for us. So
Yeah,
I
think the actual spirit of that would be that we push these guys to that functionality out of the box.
Correct. So
For the amount you pay.
The billing API is an
as you
open.
see, we pay a black box amount of euros. So.
The billing API is an open thing, right? So if you have a cloud instance, learn about the billing API, start using it. If you're a developer, you know how to deal
So
with
we
it.
can get the dashboard like this with.
You
the
can build it yourself.
usage per-
Yep.
Yeah, okay.
If not, talk to your account team and then maybe they can give you help. And if you can't do it yourself, then consulting can help you. That's the technical account manager, that's the TAM, and he does great work for booking.com, but
Yeah.
depends on how large your
Yeah, 5 out of
company
5
is and the
stars.
importance of what you're doing, that it makes sense or not.
Any other questions? Okay,
Thank you.
thank you very much. I think you need to stop the recording.
No, it's another topic.
Ah, okay, yes. And maybe they want to stop it and start the event, but it ends up in another.
It's fine, we'll cut it off afterwards.
Okay.
I don't know, but Adrian can also just cut it off. I think it's probably the easiest if we. This is just built for minions. Could be more than clicking.
We're watching you from backstage.
At the other side.
You have 1 minute to grab another drink.
Yeah.
Yeah. No more drinks. Let me know when it's too much food. You're waiting for the pizzas here, okay?
Of course, I want to take. Do you want to be in front of?
Anybody else needs a beer or everybody's good?
Now I am.
It's my time.
Perfect. Get 2 more people and then we go.
So when I was doing the course, it was also
So let's get going. ESQL, Elasticsearch Pipe Query Language. Who has heard about that already? You, okay. Some people that might have even built it. We will come back to you when we get into the very depth of stuff. But ESQL is one of the very new things. It's part of 8.11 that came out like 10 days ago or so. And it's a new way of querying Elasticsearch. And I'll try to give you a bit of an overview of where we are and what is coming and how this is developing over time. I'm Philip. I've been with Elastic for 7.5 years or so. I've done lots of meetup talks over the years, so you might have seen me along the road somewhere. We'll also be at ElasticCon tomorrow. Come say hi there. So where are we today? Where we are kind of like in terms of query languages, it almost reminds me of the matrix. You remember when there is the red pill and the blue pill, and there is the blue pill. When you take that one, you go back to your normal world where you have been before, and everything is good. Or you take the red pill, and then you have this new world that is very different. And this is kind of like what we have with these two query languages and endpoints. So far, everybody has used search. Query is what ESQL is using and has a lot of new things under the hood. Who knows how many query languages use the _ search endpoint in Elasticsearch? Or let me ask differently. Who thinks it's 1? Who thinks it's 3? 5?
Last number.
More than 5. Okay. It's probably more than 5. There are multiple ways to count this. I'm not sure we get exactly one number, but one way to look at this could look something like this. So we all know the query DSL. Like, who likes typing the query DSL? Okay, the hands are going down. So For humans, typing the query DSL is at least at first quite daunting because it has all the curly braces and it's sometimes a bit hard to debug. But there are lots of other ways how we can query data in Elasticsearch or Kibana. We have KQL, the Kibana query language. Before that, you were often using the Lucene query language to query in Kibana. Then there is the _SQL endpoint. Then there is the Vega visualization. It has its own query language. Then there is EQL, the event query language coming from security. Anybody still remembers timeline? Can anybody still write a timeline query? Because I basically know bracket and then so ESQL is, I don't want to say similar, but kind of like in terms of syntax looks a bit more like that. And then there's maybe query string. So there are lots of options of how you could write your queries. And some are very specialized, like EQL was very much for the security world where like something happens and then something else happens and you want to have these events that correlate. Query DSL came from full text search, but then took over aggregations and has this full breadth of things that you can do. And all of those have their own strengths and weaknesses. I'm not sure how you feel about KQL, but I don't think that KQL is like the most popular query language because it's pretty limited. And I always struggle with how to express things. But there were reasons why we added it in Kibana. And all of those are kind of like, they're still there, but you're not required to use them anymore. We are trying to kind of like fold all of that into ESQL and well, group that together. So just as a reminder, I guess everybody knows this and loves typing these because it's all the curly braces and all the quotes and all the commas that you might have. And it also does aggregations, but then it's even more typing. And we kind of want to get over that. So how can query languages look differently? So let's say we take the red pill and we see what happens in there. So the idea behind ESQL is that it introduces a faster, easier, and more powerful way to declaratively query, manipulate, and aggregate your data. That's the starting point of where we want to go. Let's see what is actually in there. So what you can do is you can do with ESQL, you can take your structured data and work on that. You can also take unstructured data and parse it apart within the query language right away. The language is procedural. So it's not a declarative language like SQL, but it's procedural. You basically define one step after the other. It's piped from a shell. Anybody who has used Bash or anything like that, where you pipe one command into the next, will feel very familiar or very much at home here. About the SQL-like filtering and data manipulation, maybe it depends. You tell me at the end how much you feel like SQL or something very different. And you can do things like lookups or enrichments right in the query language. And we'll take a bit of a look at how all of these work. In total, the development has started something like 17 months ago on this. So I pulled up that this was from Kostin, who started this. That was quite a massive pull request when he started putting all of this together. So yeah, he threw some stuff together and it has then been evolving and more people were added to the project. And this is how we got to ESQL where we are today. And with that, I think we can kind of try to look at what is under the covers. It's kind of small. So let me sit down like this. And by the way, if you have any questions, just stop me at any point. We can explore what is working, what is not working, what you would like to know. We don't really have a very fixed programmer schedule. I'll just try to show you a couple of things to get you started of what you could do and why this hopefully is interesting. So one of multiple ways to get data is there is basically show, which can show some information you can run from to get data from Elasticsearch. We'll also run into another one that is row, where you can add data as you go along. So for show input, this is what I've run here. It shows you that this is running 8.11.0. So this is the version where this was introduced. You can see the build and you can see the hash of this field that we're using. And you could then start piping around this to reduce the information that you get back or change it. I'm sure we could do that right away. So for example, we could say keep, and then we only want to keep the version. And then it only tells me here, this is the version, and I remove the other fields. A couple of things that you notice right away. First, upper and lowercase doesn't matter for the commands. Keep is basically the select. This is in SQL, this would be select version from show info. The other thing is you can see here, we are taking this line and we're piping it into this second one. So we're processing it one step at a time. I could also write it like this. Sorry?
In one line?
Yes, so you could write it in one line. You could also write it like this if you prefer this. Any guesses why you might prefer one style over the other? Yeah, so what would be your preference?
More lines for complex, like where clauses or whatever.
Okay, yeah, I agree.
First style will be better, especially for Git.
Yes, so that's another good point if you want to version them. Probably for readability, you want to have them. Where do you put the pipe? At the end of this line or at the beginning of the new line? Why?
You can add as many it can be changed very easily. I don't know. It's not like it should work better.
Yes. So I agree, and the reason why I think I agree is because the nice thing about this piping approach is that you can build it in a very exploratory way. You can just take it and then pipe it to the next step. And the thing is, if I remove this line here, then I have this extra pipe here because there is nothing there. So that is the reason why I think this. Oh, sorry. This is the better way. And then if I say like, oh, I don't need this step, I can just take it out and I can just run this.
Yeah. Is it possible to comment?
Sorry?
Is it possible to comment?
Yes. So we could add this back here, and then you could say this is a comment. You could also say this is a longer comment. So it's the standard Java C whatever style comment. So yes, especially if you have longer commands, maybe what you want to do is you could say whatever I do here. I think this should work. So you can just comment each of your lines of code and you see what's going on. So this was just show info. We haven't touched any actual data yet. Let's say we have the sample data set that is available in Kibana. We can just say from, this is the index name. The index name, you could also, kind of like how to select different index names. You could use wildcards. You could use commas, another index, and all of these things that you have known in the past, you can still do those and keep using those. But here, pulling that data shows me, first off, it says like, by default, it will return 500 lines or 500 hits, unless we limit that explicitly. And then it just shows me what we have in here. We could, for example, to get rid of that, then say limit 5. It will not complain anymore, and it will just show us 5 documents that we have returned. Knowing the underscore search endpoint, any guesses what will happen when I, rather than using post, if I use get? Will this work? Will this fail? Sorry?
Should be the same.
Error, because get requests are not supposed to have body.
Yes, so that is the long discussion with the REST API. what is the right HTTP verb for reading data and should it have a body or not. So for this one, we have decided it needs to be post, it cannot be get.
So you are actually consistent this time.
I feel like there is no consist. I think both are inconsistent in their own way. I always feel kind of weird about reading data or fetching data with a post.
But otherwise, you say in the command. Yeah.
Otherwise, there is no body. Yeah. I think there is a new HTTP RFC that is actually search, that is for read on or reading and has a body defined. But nobody supports that. So it's kind of like a nice theory, and I'm not sure we'll ever get to that. Okay, we've already seen that I pulled some sample data with this limit, and then it's not complaining about the default of 500 anymore. We could combine it with the examples from before where we say, okay, we want to keep just these 2 fields, and then we want to limit it to 10 documents. How similar is this to SQL in your opinion?
So similar.
Yeah,
Just changing some names.
Yeah,
I have a conflicted thoughts on this because it's obnoxiously similar, but not.
Yeah, I think it needs some getting used to, because otherwise, yeah, you see some keywords like limit and from that are familiar, but keep is different. And
the piping thing is more like what you do in a shell script.
Yeah, and it's procedural. You define the steps. It's not declarative that the query engine will totally change this, but you.
Does that mean that the order in which you put the steps also matters for the performance stuff? Like if you do limiting first, then the next step will have to search through less data or process less data or stuff like that.
Yeah, I think that will make a difference if you.
Yeah, because that's important because that's query performance in a nutshell.
Yes.
If you limit first, a lot faster.
Yeah, it will but it will totally change your results.
Yeah.
I mean the.
Do you have an explain like explain?
Not yet. So there are quite a few things that are still on the roadmap to be added. The deeper debugging of what is happening behind the scenes is one of those.
Do you support cross-cluster search on this already?
No, not yet. That's one of that's one of the higher priority things that we're working on. But I'm not going to promise any versions here. One thing so far that we've always done is like previously we were always used to JSON. Now the output format was just text. There are multiple options of how you can define the output format. So you could just say like, oh, this should be a JSON. And it says like, these are the columns that are available with the field name and data type. And then you get the actual hits in an array of arrays in values out. You could also say, for example, I want to have this as comma separated values.
Can you do it one JSON document per row instead of a JSON document with headers and then arrays of?
I think it's called JSON lines, JSON L.
I don't know if we can change that. I have not seen that option anywhere. But no, so far, these are, I think you have tab separated values as well. But the documentation has all the options that we support today. Now, for another example, what I've mentioned before is like we have this row. Basically, this is for testing more or less. Here, I'm just saying this is the data that I want to use. And then I'm doing a dissect here. Who remembers what dissect was? What is dissect?
Breaking out a line according to a predefined pattern, kind of like the antithesis of regex.
Yeah, I would always call it the little brother of regular expressions. So it's much simpler because it basically says like there's something here and then there is space dash space, and there are some more constructs where you could combine different things, or you could say like, oh, eat all the spaces that are in between here. But it's generally very very kind of like you have one element and then another element. It's much simpler, but it's also much faster than regular expressions.
It kind of looks like mustache or something.
Yeah, I mean the placeholder syntax is used by multiple languages. Yeah, so you have that, but it is to break this up. So we'll take this line here, and then we'll break it up on this space dash space and the other one. We only keep date, message, and IP. Why am I doing this? Because I have date, message, and IP anyway. Any guesses?
Yeah, remove the dashes.
I think because you don't have columns here and you need to define them.
Yeah, I think you're dumping A.
Yeah, exactly. We're dumping A, which is, by the way, a good thing to show. So here, this is kind of hard to read, probably because you have A, date, message, IP. So this is A, and then you have here date, message, IP.
Make it TXT and then it's going to be easier.
Yeah, maybe it's easier to read with TXT.
Not really.
So yeah. So if you zoom or put it over here, it is easier to read. But if you add the keep, then we're only keeping those. And then we could also make sure that we evaluate date to actually a date time, and then we could keep working on that. So sometimes you need to massage your data after that a bit. We can also do full-blown regular expressions or grok patterns. For example, here grok knows what an email looks like, and it will make sure that this value only parses a proper email. So it knows what an email address looks like, and then we'll put it into a field email. So I can also run this with a regular expression, and it will parse this apart in the right pieces.
One question.
Yeah.
Why it's changing the, for example, in keep, we have date, IP, email, number, but in the chart, when it's returned, it is the columns are not the same. Because in the next line, we are changing the date. If we do changing, the columns will be changed.
You mean if I remove this one here?
Yes.
Yeah. So
last modify goes to last.
Yeah. Oops. So yeah. So we have the order like date, IP, email, but then we do something with date again.
And if we want to keep our previous order, we should use another keep.
Yeah, I think that should work.
I think if I read the way, it's because you're overriding the type, right? You had a date, which was the first, then you overwritten the date with a new to date time, and because you overwritten it,
yeah,
went to the end.
you overwrite the field, yes.
Yeah.
It is overwriting, but for us, it's not an override.
Because it's not really SQL. That
It's not doing any execution.
Yeah.
But I would say it's expected from a procedural kind of workflow.
Yeah, I guess what is expected is, yes, I guess you get used to what is expected here.
Actually, I have another question. Do you have some kind of exclude comment? Remove the column, because I think it's.
I mean,
like,
yeah, we have a drop.
Cool.
So you can also just drop.
Can you drop columns or does it drop lines?
I think ignore or skip will be great. Drop users.
Drop Bobby tables. So if you enjoy writing regular expressions, you have all of that power and you can do that anywhere right in your query. And I always ask, like, who enjoys writing regular expressions?
Oh, come on.
Yeah, that's kind of the Stockholm syndrome, right? Yes, of course. You get so used to writing all those regular expressions until you really enjoy it. Other examples, we have an evaluation where you can do calculations, and this is either adding new fields or overwriting existing fields again. So here we have me and my height in meters. And then I want to add the height in feet and the height in centimeters. Yes, so we keep the 3 original fields, and then we add the height feet and height centimeters, and get those out here.
You can round.
Yes, there's also a round function. This is actually the next part where we have functions. I'm not doing round, but I'm doing on the sample data set, I'm counting the distinct client IPs, and I'm also counting the average of the event duration, which are 2 fields that are in that data set. Let me just quickly show you again. So we have client IPs, and you see it's not many. And then we have the event duration, and we could, for example, just calculate those, and then it runs under the hood, distinct count, and averages the duration for us. So you can run function on the data.
So this one grouped, right? So it's grouped by count and then made average per group, or it's not connected.
No, yeah, it's 2 separate.
Okay, and can you do what I'm asking?
Can also do group by, yeah. Okay. We'll go to Discover, which has much better documentation. I think that will make it a little easier afterwards. What I'm doing here right now is the more complicated approach, just to show a bit what is happening, and just to see without all the bells and whistles that we have otherwise. Another example that I put together here is we keep the timestamp, the client IP, and the event duration. We parse the client IP. I think that is an IP field and not a string. We make it a string. And then we can run an enrich policy on another index. Who remembers how enriching worked in Elasticsearch? Otherwise, for that one, I also have like the slide. So this is like maybe the little brother of joining. I don't want to call this a full join, because enriching, at least as it is now, is not doing what all the bells and whistles that joins can do. But the enrich is like you have one or more source indices. You create this enrich policy. You execute that to get it into an optimized format. And then you have, from your input in the top left corner, you have an enrich command, and you basically enrich on this A, B, C, D from the input. You enrich that from the enrich table, so the A will get enriched on the A, etc. So you have basically this part here is this part here, and then these will be enriched as the red column matches. And that's how the enrichment works. Right in ESQL as well. So here we have, we have an environment based on the client IP, and the client IP, how the enrichment works, this is only based on a match for ESQL right now here. So this is a match on a string. So the client IP basically added that environment column here to our data set. And then you could, after doing enrich, just doing the same thing as before, based on the enrichment, you can then do more calculations. So for example, here we are doing the median duration by the environment. And then it will say this is the median duration for those 3 environments. So this is the group by that you asked for, of how to combine those. So this is everything that you can do by hand or from the API. One of the big advantages here is that this is also fully integrated into Kibana. And you don't need one query language on the API and one in Kibana for KQL or for alerting anymore. But the idea is really to combine all of those together. Where do you find ESQL now? So how to get there is, if you have your list of data views, you have this try ESQL at the very bottom. This is how you switch over. And then it will give you an example query. Here we have from Apache logs, we limit it down to the top 10 results. If you write a very long query, you could also make this larger and then start writing this in a nicer format again. So if I run this, if my browser window is small enough, then you can see here all the documents that are matching, and then we could do a keep again. I don't know, we could just do a keep on this one, or actually, maybe it's good to see. So if I say here, it autocomplete. So for example, I could say, I want to keep, and then it will also autocomplete my field names that I have available. So what did I want? GRP, I don't know, let's say country name. And with command enter, you run this, and then it will just give you those.
Can we use it in watchers also?
I don't think it's supposed to available in Watcher, where we will get to alerts in a moment.
Okay.
But Kibana alerting.
Sorry, I forget or missed how to filter data. Country name we call assumption.
Where?
Yeah, there's a where clause. So this is, by the way, a great point. If you don't know what you want, we have the reference built right into the UI. So these were the three sources that we looked at. And then we have these processing commands. And the where is the one you're looking for in that example. So this one is very similar to SQL again, which can sometimes be a bit treacherous. And then, so normally this is the normal zoom level that you would have. And then you can see how the where functions, and it has an example, and you have all of that built in. So you don't have to go to the documentation if you get lost or forgot how something works. It's built right into this one here. So let me zoom in.
Can I ask,
Sure.
Apache logs, is it in index?
Sorry?
Apache logs, is it an index?
Yes.
And does it work with database?
No, no.
Yeah, so this is the index. We could also say, I don't know, whatever, but those you basically define like any other. And then we could have, I don't know, I think we have log slash as an index, log slash star, and we could filter all of those. And since you asked about the where, let's add a where clause. And instead of, maybe this is good. Okay, so we want to say where, and we say GeoIP user code equals. Where are you from?
Uruguay. UI.
UI?
Yeah, that's it.
Case sensitive?
Yeah, it is case sensitive. Okay. So we have one hit here. The case sensitive, by the way, is a very good point. All of the operations are like keywords. So they are case sensitive. We don't have a lowercase or uppercase function yet. What is the workaround?
Use text. Okay.
No. What could be the workaround to that?
An or?
Yeah.
Regular expression. No.
Yes, it's always regular expression. Yes. So there is an rgrep function that you can use. So you could fall back to a regular expression. But we hope we will have better solutions for stuff like that soon. So you can write horrible things in regular expressions here or combine horrible things.
Someone with a lot of Stockholm syndrome said that was good enough for.
Yeah, because somebody said alerting before. Up here we have alerts, and then we can just create an alert, and we can give it a name or whatever. And this will keep the ESQL query that we have just done. So this is pretty cool because you can just explore your data and filter down on things you're interested in. And then without having to copy it, it will keep the same query. And then you can say the conditions on what time frame, and how often you want to check, and you can test your query. And then that's how you can write your alerts. So you don't have to go into multiple places or to write different queries. You can really just start exploring from Discover and then write your alerts from there. The same goes for visualizations. Let me open one of the many things that I think here we have a time histogram. I think that should look a bit more interesting. So you can see here that this is our query. By the way, the queries always warn you if there's something that it thinks is off. So here, for example, we didn't define a limit, and we're relying on that 500 limit. So that's why this warning is here. But here we're going for the Apache logs, everything that is a login. We auto bucket based on the timestamp field between those. And then we do a count on the username by time bucket and username, and then we sort that by login attempt. So who has tried to log in how many times in a specific time bucket? Make this smaller again. You can see here we have some visualization, but you can totally customize that. Oops. So you can say, oh, here I have a vertical stacked bar chart, but we could also say we just want the regular bar chart. We could say we want to have, I don't know, right now it's colored on the username. Maybe I don't like the color scheme and I can change the color scheme. So this is just like Lens, but built into Discover. So you don't have to head over to Lens. You can just slice and dice your data, and then you can build your visualizations right here. And you can go back, and this is a demo environment, so you cannot save anything right now. But in normal Kibana, you would have a save button here at the rightmost button that is kind of like, I think has a dark blue background. And you could save the visualization right that it is here as a Lens visualization and also drop it into a dashboard. So you can build those, and you can also edit your visualizations right as ESQL in a dashboard. So you don't need to create them in any different way or jump around widely. So it's 1 minute past 8. Let me do the rest of the slides. If we have more time before the pizza arrives, we can do more demos, or you can keep asking. But let me do the important stuff first, or let me finish on two more things. One thing that is always relevant, because we were talking about cost optimization before, is performance. And so we have in the Elasticsearch benchmarks, there is an ESQL benchmark that benchmarks ESQL and also classic aggregation. So this is probably hard to read, but this says Search X. So this is the classic non-ESQL aggregation. And then we have different ESQL visualizations. I think we switched from shard partitioning to segment partitioning. And you can see here, this was the search aggregation and took like, I don't know, 15 seconds for whatever average amount group by integer we were doing. And if you do the same query with ESQL, with segment partitioning, it's like a fifth or so of the time of how long it takes. It's not guaranteed that every single query will be faster, but many are. And we're working on making more of them faster than the query DSL.
Are you backporting that to the normal DSL?
I mean, the normal DSL will get faster because, yes, we fix some things, like, for example, for aggregations, we've added some parallelization now. Lucene will also make it faster, but it's not all the features from the ESQL will go to the query DSL. So
is your intention to move people to ESQL entirely instead of the DSL, or?
That is a very forward-looking statement, and I think there is a big it depends. So I think there will be some use cases where it is pretty appealing now or very soon, especially around observability and security. Full-text search is a bit more of a question mark since we have not really implemented full-text search features there yet. So there you're, I don't want to say stuck, but you're well served by the query DSL. Whereas for security and observability, you might start playing around with ESQL now because it makes your life easier. Also because, in my opinion, nobody loves KQL. I mean, maybe somebody proves me wrong here, but I have yet to meet somebody who says like, I absolutely love KQL.
I ask because I know users who have sunk time into learning the DSL, right? And for me to tell them,
yeah,
your queries will be much faster, but you need to learn yet another query language.
And it will not work with cross-cluster search.
So it's that kind of trade-off of if these optimizations are only going to be available with the newer iteration of the language, or how your points of deprecation and so on.
So, coming back to this, the actual syntax of the queries is just one part. There's a query engine under all of this, and that is how we try to make all of this faster. And this is the difference to before, because before you had many times, like SQL, for example, was transpiled or translated to the query DSL. Here we kind of like started from scratch. So it's not just the syntax that changed, but it's really how the query execution works. And we also try to push more of the queries down to the Lucene level to make them more optimal than before what the query DSL was doing. And we do take more advantage of multi-threading and try to optimize more in that query language, things that are not as easily possible in query DSL anymore. So there's another big driver besides the language itself is the engine. And then, like I've shown you, the visualization and how all of those tie together, that's the third component. So it's kind of like these three things combined are what ESQL is. So ESQL is not just pipes in your query, but it's really three different components combined. I've shown you the benchmarks. If you want to see what is not possible, we have a page, ESQL limitations, and I hope that that page will get smaller over time. So if you have anything, flattened fields, nested fields, IP ranges, there are various field types that we don't support right now. Async search or pagination is not supported. Cross-cluster search, time series data streams. There are quite a few things that we are actively working on. This one here should probably go higher up on the priority list, and full text search, for example, is a bit lower. But we're working on these to get all of those sorted out and make ESQL feature complete. What is important for going GA, because right now this is a tech preview, it's less about the features. So the next minors will probably be more around the stability, consistency. There are quite a few things in Kibana to fix as well, documentation to be improved, just to make this more stable and usable so that what is out there to be in top shape. And as we go along, we will add more functions and other features to the language. Though things like CCS is very high on the priority list for that. So to wrap up, this one is almost more a discussion point. Depending on where you stand, like I feel like different vendors or tools have different approaches here. The Elastic approach is very much that we want to have one unified storage engine and we want to have one unified query language. Whereas other ecosystems tend to have like different backends and different query languages for different tasks. And our opinion is that it's much easier to have one unified way of working with the data that works for different use cases and different backend specializations, regardless if it's metrics or logs or something else, to combine all of those.
So what is the timeline for one to rule them all?
So I know that some people have the one to rule them all. So I always feel like that has a bit of a negative connotation.
Yeah.
Right now we're in tech preview, so that there will be some more time until it's actually GA, and then that GA doesn't mean that it will be feature complete yet. So there will be a bit of a longer path, like to getting rid of the one. There's a bit of a path to that.
But when is it out then? Or when's the release?
No, this is already out. In 8.11 that came out 10 days ago.
Yeah. So,
Or 2 weeks ago. What I've shown you, this is out and you can use. We will work foremost on the stabilization and making things more consistent and adding a few things in Kibana and in documentation. And then we will expand the feature set mostly. So that's the next few months. And beyond that, I feel like we'll figure out what is most important and what is most missing and demanded by people, and how we can put all of that together. If you want to try all of this out, either you download 8.11 and try it out on your own machine, or you can just go to ESQL demo elastic.co. That was also the place that I was using. This is where all the documentation is. It's pretty easy to follow along just to give that a try, or you use the Kibana.
We were forced to.
It doesn't work on CCS.
No, that's right. You should move to 8.11 anyway because of the vulnerability. So
the approach is that you should always be on the
today because of that. So
the current version is always the best version. Hopefully.
I believe you for Elastic, but not as a general rule for.
Anybody heard of regressions?
I mean, sometimes there are regressions, but there are also a lot of bug fixes in every release. So
there's a reason why the bleeding edge is bleeding.
I mean, maybe you want to wait for a 0.1. We've had quite a few 0.1s in the
8.11.1 is already out there.
Exactly.
Yeah.
So you're
it's
good
the
to
one
go.
we installed today. Yes.
But that's the kind of like the price for adding a lot of features.
Question before you go. So are you planning, do you have a target ESL of the queries that you plan to kind of deprecate or implement via ESQL behind the hood? Like you plan to move the SQL endpoint to use ESQL behind the scenes in the future or any of the others?
I don't. Right now, there are two different worlds, and I'm not sure that they will ever cross.
I'm asking because in a world where you're talking about a unified query language, right? You are going to have to deprecate the other ones at some point.
But I mean, we have, at this point, we have like a zoo in query languages.
Yeah, that's why I think you would plan. I mean, this is my inference, right? You would plan to, let's say, identify one of these and say, yeah, we're going to rewrite the entire API so that you keep the interface, but you implement it via ESQL behind the scenes.
Yeah. I mean, you mean for like dashboards that we provide and things like that?
Whatever use case, like let's say somebody writes a timeline query, and behind the scenes it actually moved to use the SQL behind the scenes, so people can still write a timeline query, but that's no longer the implementation.
I would not recommend anybody to use timeline.
Of course, I mean it never actually worked.
Yeah.
So
it's
no, because I mean, the meme from XKCD comes to mind. Yet another query language. So
yeah, all these standards are bad. So I'm going to create another one to.
These are not even standards, but yes, we will see. We also have, I feel like this thing where it's like, oh, we have Kibana alerting, but Watcher is still a thing. So it's very hard to kill something that has been successful. I don't see.
Timeline was successful.
Yeah, timeline is here.
It was deprecated.
But quite a few of the others will be very hard to get rid of, and especially QDSL.
I mean, that's what I mean. I mean, a way of getting rid of them is that they are no longer the main interface to the backend. That instead of they're just translators for ESQL.
I mean, that is I think one of the ideas behind having a query engine, that you can plop new query languages on top of that more easily. That does not mean that these existing ones will be.
Okay. So my interest behind this is about feature starvation, right? So if you're going to put all your efforts into ESQL, how do we expect the other query languages to evolve? Because particularly when you show such a big difference in performance between the normal query DSL and ESQL, it's like, we still have a lot of users and we will keep having users on the normal query DSL. So we want that from those performance improvements. We don't want to get starved of that performance because you are putting all your effort into ESQL. So that's why I'm interested in how you're going to proceed.
I mean, I feel like starving is maybe a bit too strong because it's like, it's just how the implementation works. Like not all of these changes or improvements can go to other query languages. It's just built on a different foundation.
Yeah. Fair enough, right? But if a query DSL can be equally fast in both because they are compatible behind the scenes, I would want that the query DSL, the normal one, does leverage ESQL benefits behind the scenes if it's a target for those because it could be translated to SQL. Like, and I'm not doing any full text search, right? It's a tall ask, I know.
Yeah,
right?
I'll give you a private answer.
No.
Cool. So it's 1:15. If the pizza is not here, I guess we can just go back to Kibana and yeah, please. Sorry.
About the query language itself. Is there any chance that you are joining or already joined the query standardization? Yeah.
Yeah, I mean, I'm aware of the discussions. I'm not sure what our official status or involvement right now is. I feel like there will be an interesting one because I have the feeling there are quite a few players in there that try to make their own query language the standard, or at least find a standard that is or that works well with their backend and the way they query data.
But if everyone joins, including Elastic, then the interest is for every player. And it's mostly about us, the users.
Yeah, I
want to learn only one language and not learn.
I know. I hope that with the query DSL we have with ESQL we have a better starting point. And again, like this plopping new query languages on top if needed. We'll see. The problem is ESQL is kind of out of the door, at least in parts now, and I doubt that what the standardized CNCF language will be is the same. So we will see. I have the feeling everybody in the ecosystem right now is a bit like watching and trying to figure out where this will go.
But let's see OpenTelemetry, for example.
Yeah,
kind of became something that is really useful for everyone, not only for one player.
Yeah. I mean, it's kind of beyond the current standardization of the OpenTelemetry.
Yeah, of course.
Device.
OpenTelemetry is the thing to look up to.
Yeah, and I mean, because it's like behind OTLP, then it's the Wild West where everybody has their own backend visualizations, query language, whatever.
But at least everyone accepts the same format.
Yeah.
That will be everyone accepts the same language, and then you can have all your specific things after.
Yeah. You know, there's a reason why some people call it Hotel California, because everybody is welcome and can join, but nobody can leave. It's like once your data is in the backend of a vendor, it can never leave again. So we'll see how that will with query standardization play out. I feel like everybody has hopes or expectations, and we'll see how they play out over time. Yeah.
One more question. Client language support for the original language is very good. How about the SQL?
Soon. So the thing is, the clients team has been doing a lot of stuff. Maybe you have seen that we are doing a serverless offering of Elastic Cloud. They released a set of clients because serverless reduced the exposed API surface drastically. So you can keep using the current clients with that, but you don't know which API endpoints are available. So there is a new set of client libraries just for serverless because they only have the API endpoints that are available there. That came out like a month ago or so. And since then they have been working on ESQL, but that is still mostly work in progress. There will be clients. Talking to that team, I feel like they were like with the different output formats and everything, they felt like this was pretty hard to work with because JSON was relatively easy to work in most languages. That more textual format might be harder to work with. So we'll see exactly how much tooling they provide, or if it's basically like throw this string against this endpoint and I do like retries or error handling, but I'll give you back whatever comes back. I'm not exactly sure how that will look like, but that's more in the development phase. But yeah, the clients will support that. But also as features grow, that it's a moving target. So I think it will take some time until that is fully out. But yeah, I think right now, if you do observability and security, especially in Kibana, ESQL is already a great choice and you can use that. In your language client or for your full text search projects, it's probably not quite as useful, but we'll change that as well.
Thank you.
Pizza is here. Okay. If you have questions. I mean, it's still a lot of work. Yeah. Are you involved? Yeah, no, I know. Are you involved in any of this?
I will. I do like the way it's presented as well, like the offense, really about the security part. I think when you compare to Splunk, it is really, but most of the people are wondering about the search, right?
That is.
So I'm quite excited when I saw. I was like, "Oh shit, this is pretty cool."
No, I also think that, and I know how long it took me to learn the QEDSL, and I feel like with this it's much easier to get started.
I also feel like that. I feel that reading is so much easier. So you can read quite easily, in my opinion.
I mean, it still has its own quirks, like the email and stuff like that. I'm not fully used to that,
but it's better than the DSL.
Yeah, no, it's better.
No, I like it. I'm quite excited, especially as I said in the security department. You have so many data coming and then filtering. I like it.
For show ben goed genoeg voor visibility and for
Thanks, we see.
Nice to meet you for a long time.
Hi, yeah.
From Fuji.
Yeah, I know. Yeah. Yes.
It's great to last.
You were always based in Amsterdam, right?
Actually, I lived in Vienna for some years.
Ah, really?
Hinten die office. Small district.
Why did you do that?
Why did I do that?
Yeah.
Vienna is amazing.
Okay.
Gerelateerd aan kostentransparency. Ik weet niet of je het gezien hebt. Hier zijn de Universal Profiling. Universal Profiling kijkt naar de code.
Before I even knew about Java, after I went to Prague.
Je kunt de code bekijken en dan zie je allemaal balkjes. Rood en groot is niet zo goed. En dan zie je wat het kost per uur.
I thought you had been in the Java ecosystem.
Die code die niet zo goed. En STKI is geef je ook advies over hoe je die code zou moeten herschrijven.
Okay, so not the late 90s or something.
Dat gaat nog wat. Ik had dat hier eigenlijk verwacht. Je stel een vraag en laat de code genereren. Ik denk dat zal straks ook wel kunnen.
Right.
Dat is gewoon basic knowledge.
How is it going in the Zoom?
Zou je dat moeten kunnen?